So this is the video for Chapter 8, Lesson 1. So we have just ended a previous chapter on polynomials and monomials. And let's review a little bit. When we multiply a monomial and a trinomial, we can use the distributive property. And I know we've talked about the FOIL method and the box method, but we can also use the distributive property. So let's review here with a parentheses. When we have a parentheses, a monomial and a trinomial. So this specific one, we've got a trinomial and a monomial. We want to distribute this in and get rid of our parentheses to simplify. So 5n times n to the third power would be 15n to the fourth power. And minus 5n to the third plus 40n. 5 times 8, 40n. So that should be pretty straightforward for you. Well, what we're going to focus on in the next few lessons is the factored form of our terms, monomials, polynomials, and so on. So we're going to start simple. Factored form is when a monomial is expressed as the product of prime numbers and variables with no exponents greater than 1. So this word prime number means a number that can only be divided by 1 in itself. So some examples would be like 1, 3, 5, 7, 11, right? These would be examples of primes. And so these are numbers that can't be divided by any other number except for 1 in itself. So let's factor these monomials completely, which really means we're going to break it down so that it is just a multiple of a bunch of prime numbers that when you multiply it all out, it becomes the actual monomial we're looking at. So one method to factor is to use the factor tree. And I don't know if you have done this in the past, but the factor tree is really just looking at one number and breaking it down into its product one at a time or a pair at a time. So 34, we know this is an even number, so I could divide it by 2, right? So if I plug this in, 34 divided by 2 is actually 17. So that means 2 times 17 is 34. And now 2, actually, I forgot to put 2 up here as one of the primes. 2 is a prime number because only 1 in itself can be divided into it. So 2 is a prime. But can you think of any number that can be divided into 17? I don't think so. I don't think there's two numbers besides 1 and 17 that you could divide 17 by. So these are primes, and I like to get in the habit of circling my prime numbers. That's how I know I'm done when I'm working out the factor tree. So that means 34 can be broken up as 2 times 17, and then x to the fourth power is really just x times x times x times x, right? X times itself 4 times. And then y to the third power would be y times itself 3 times. And so this is the factored form of that monomial. Okay, let's look at negative 52. Well, first of all, this negative symbol, we always want to bring that out because when you have a negative number, it really means negative 1 times whatever the positive is. And so it'd be negative 1 times 52, except for I know 52 is not a prime number, so I need to break that down. I'm going to use my factor tree here. And I'm going to start with dividing it by 2 just because I know it's an even number. So I know 2 has to be divisible by it. And 2 times 26, if I plug that in, right, divide by 2. 2 times 26 is 52. So I'm going to circle 2 because that is one of my primes. But 26 can be broken down some more. So I'm going to break it down by 2 again. 2 times 13 is 26. So 2 is another prime, and 13 is a prime as well. So that means negative 1 times 2 times 2 times 13 makes negative 52. Then I'm going to break down the variables. That would be A times B. And that is the factor version of that monomial. So if we're looking for the greatest common factor of multiple terms, what we're going to do is we are going to factor each monomial and identify all the common factors that each monomial has. So here's the instructions. List the factors of each term, and then identify the factors common to all terms. So let's talk about what that means. Let's factor these terms. Well, I know 3 is a prime, so I can't break that down anymore. It'd be 3 times x times x times x times x. Well, I know 9 is not a prime because 9 times or 3 times 3 makes 9. So when there's a negative, bring the -1 out. -1 times 3 times 3 times x times x. Okay. -12 can be broken down as -1 times 2 times 6, right? Right. So I've got 12, 2 times 6, and 6 can be broken down to 2 times 3. So 2 times 2 times 3, I'm going to circle these, are the primes. 2 times 2 times 3 times x. All right. Now I'm going to get a highlighter here, and I'm going to identify all the common factors amongst all 3 monomials. So I've got a 3 showing up here, a 3 showing up here, a 3 showing up here. And then I have an x showing up here, an x showing up here, an x showing up here. All of them have in common 3 times x. So what we identify as the greatest common factor is 3x. So you're looking at the factors that are common to all the terms. All the terms have in common 1 multiple of 3 and 1x. Let's take a look at this set here. What is the GCF, greatest common factor, of 9x to the 6th power plus 15x to the 4th and plus 12x to the 2nd? So let's break down our first term. That would be 3 times 3 times x, right? 6 times. And then 15 would be 3 times 5, right? Right? 3 times 5 times x to the 4th power, so 4 times, 4x's. And then 12 would be, we did that earlier, is 2 times 3, and then times x times x. So let's highlight our common factors. Each one of them have a 3, and each of them have a minimum of 2 x's. So the greatest common factor is 3x to the 2nd power. Next one. All of these terms are negatives. I would encourage you to circle the term with the sign that comes in front so that you know that when you're factoring out each term, you remember each term is -1 times the positive prime numbers. And so we've got 2 times 3 to make 6 times x 4 times, -1. I might have to do a factor tree here. So that'd be 2 and 9, and then it would be 3 and 3. So 2 times 3 times x 3 times. Lastly, 12 is factored out as 2 times 2 times 3. We did that earlier. X times x. Okay, I'm going to identify all my common factors. They all have a -1. They all have a 2. And they all have 1, 3 and a minimum of 2 x's. So their common factors are -1 times 2 times 3 times x. Let me actually bring all these numbers together and write it as one collective term. That would be -6 x to the 2nd power. So that is the greatest common factor of those terms. All right, I'm going to stop here. It's pretty as simple as this, but we are going to piggyback off this with our second lesson, so make sure you watch that video as well. I'll see you there.